let's start off redoing this problem. So concave up and increasing. Again, we know it looks like this. Concave up and increasing. It has to have that curvature to it. The curvature. So as I'm increasing, I'm making sure that I have that concavity, okay, until I get to here. Now I need to go concave down, so the concavity switches. Notice that switch right there. Concave up to concave down. I'm still increasing, but now that curvature is more pouring out. That's going down. Until I hit right here. And right there, I'm still concave down, but now I need to go to decreasing. Okay, decreasing until right there. Point of inflection. Okay, now it needs to be concave up. I need to end off right there. Notice that curvature change. And it's hard to do on this board, but hopefully you can see it. The curvature change here to where it's holding water to pouring out to holding again. I could do that better, probably right there. There you go. Okay? Hopefully that makes some more sense. Maybe it looks better like that. And behavior is still 0. So that's attempting the graph of that. So the second derivative test, one that I don't use too often, but one you can use if the derivative equals 0 and the second derivative is greater than 0, then we have a local minimum. Meaning that if concavity is greater than 0, well, we know it looks like, it would help if I could actually draw it. It looks like this. You have a minimum. Where concavity is greater than 0 or less than 0, we have a maximum. So now let's look at this entire curve, and I'll go through the problem one more time with you guys. So discuss the curve y equals x to the fourth minus 4x cubed with respect to concavity, points of inflection, local maxima, and local minima. And then use this information to sketch it. So first thing we're going to do is y prime equals 4x cubed minus 12x squared. I'm going to set y prime equal to 0, which implies we can factor out a 4x squared, and we're left with x minus 3 equals 0. We can then say that implies that x equals 0 and x equals 3. And then, now that we have our critical values, so these right here are our critical values. So now we're going to do a number line. 0, 3. And so we're going to look at y prime of 1, y prime of, negative 1 there, y prime of 1, and y prime of 4. And so I'm going to go back to the factored version of the derivative. Negative 1. Negative 1 squared is a positive. Negative 1 minus 3 is a negative. So a positive and a negative, negative. We're decreasing. 1 squared is a positive. 1 minus 3 is a negative. Positive and negative, also negative. 4 squared positive. 4 minus 3 positive. Positive. Okay, so I know I'm decreasing. I'm decreasing from negative infinity all the way to 3. And I'm increasing from 3 to infinity. We should have brackets here. Okay, my relative minima is x equals 3. And I do not have a relative maxima because we never went from decreasing to increasing, or increasing to decreasing. So to find concavity, because that's our next part, concavity y double prime equals, well, let's go back up there, 12x squared minus 24x. Y double prime set equal to 0 implies if we take out a 12x, we're going to get x minus 2 equals 0. And so therefore that implies that x equals 0 and x equals 2.